Hello, everyone, and welcome to the ML and IoT lab. This is going to be part one, so we're just going to do a quick introduction to the lab, some of the topics involved, and the tools that we're going to use throughout it. So first, just a little bit about myself. My name is Peter Matev, and I'm currently working as the leader of the design computation team for NBBJ and our offices worldwide. So below that is my contact info. Feel free to reach out if there's any questions about any part of this lab, as well as a link to my GitHub where you should be able to find a lot of this code, obviously, and other code in similar kinds of veins. So feel free to explore that and see if there's any other examples you might be interested in. And last is just a link to my website if you want to check out my work in general. You're curious about what I do day to day. I think the graph on the right kind of gets a good explanation going at least. Currently, I'm really focusing primarily on web technologies, and I've just kind of listed some of the tools and technologies that I work with most often in my day-to-day application development. So this slideshow is also available. There is a link obviously at the bottom that you're welcome to copy in your browser or a QR code if that's somehow more convenient for you. But this slide deck is available and a lot of things throughout it are going to be hyperlinked so that you don't have to dig for them yourself. So feel free to check that out. All right, so first let's talk a little bit about the project and the medium of how we're going to do this thing. So we're going to be using a platform called Glitch. And if you're unfamiliar with Glitch, I highly recommend checking it out. It's really hard to explain and really just pin it down what it is. I think they're trying to diversify that even every day. But I think primarily it's a good environment for building small scale web applications. Um, they have a browser integrated IDE allowing you to code. They also do the app hosting for free. They're basically creating these little dynamic runtimes which go to sleep when your app isn't being used and then they wake up when you need to use it. But the best part again is that it's free and it's very accessible. And you can also look at other people's projects, clone them, fork them, and there's some other cool features we're going to talk about as well, like being able to go back in time, which I think is going to be really, really helpful for this lab. So this is also going to make sure that we don't need any kind of installation. If you don't have any IDEs or any packages installed, that's fine. This is all going to be browser based. Everything is going to be there out of the box. So which is going to make it a lot easier for us to be on the same page regardless of skill level. So this is what the project page is going to look like. And again, this is hyperlinked as well if you just want to click it when you get this slide deck. Um, we have a series of modules, and currently we have 8. We might add a little bit more, and there might be some editing even after this video is released, just based on people's feedback. But um, it's meant to be chunked up and really accessible. So we're going to take it one step at a time, and it's not going to be this kind of long monolithic slog where if you don't follow along for a portion, you're kind of lost forever. There's always going to be a stopping point for you, and these are public things which you're going to be able to copy, play with, and nuke and start over if you mess up. So I'm hoping that this is just going to again make it really easy for everybody to follow along regardless of skill level. So parts 1 through 4 are really going to be about the sensor capture and analysis. And for that, we're going to be using Vue.js and Tensorflow, and TensorFlow's JS implementation, which is actually pretty well at this point, not that recent, but recent enough. It's TensorFlow.js, and this might seem like a bit of a kooky combination to you, especially if you're more on either the data science side or the IoT hardware and software side. Yeah, and yes, this is a little bit weird. I'll say it outright that this isn't really the enterprise grade stack that you would use if you were deploying this at scale and trying to make money off of it or something like that. This is really just meant to expose a lot of different technologies that are current and emerging, and just show how accessible and easy to use they can be. And you'll see what I mean a little bit later if you're in that more experienced group in the actual, production side of IoT devices. But for the first part, we're going to use Vue, and that's really just going to be an interface for us to just see what our camera's seeing. And we're going to use TensorFlow JS to be able to do some analysis right in the browser without sending any data back to a backend or a database, anything like that. So And we'll talk a little bit about why that's important as well. Parts 5 through 8 are gonna be close to wrap up for us. So we're gonna use a library called Brain.js to build some very basic neural networks. And again, this is a very accessible library. It's very high level. It exposes a lot of the most critical parts of creating a neural net, but it doesn't go into huge amounts of depth where we all need to have domain specific knowledge in order to understand. So I think it's going to allow us to play around with things, and there's always more documentation out there and resources if anybody wants to get a little bit more in depth. And I should have a collection of those as well as we get closer through those modules. And there's some alternate parts as well that I listed. So if you're one of the more advanced people looking at this workshop and you might get kind of bored, here's a couple of options that you could help us out with, and maybe create a couple more modules for the community that might want to expand this project a little bit more. So an alternate part would be alternate integrating a database. For this series, we're really just going to be logging to a text file, an Excel file, something very basic. But again, if you were trying to set up a slightly bigger project, maybe a little IoT network for your home or your office, you'd really want to be pushing the data to a database. And I think my personal suggestion, just for accessibility's sake and knowing that we're working in front end, would be to use Google's Firebase. I think it's again in the vein of accessibility and ease of use. I think it's right up there. And it has some very cool features like being able to listen for data changes live and subscribe to events, um, which is pretty cool. So there's another part we can implement as well. So we are going to be using the image recognition model for this lab. So what that means is our camera is going to be looking at us, and it's going to try and determine that we are a person. There's another way that we could achieve a very similar result, or even just create different data, which is using the PoseNet model. So rather than just identifying the image, the PoseNet model is already looking for people, and it's looking for appendages. So this could be, again, another module of data that we add to the functionality of our IoT device. So currently, we're going to try and count the number of people in a room, count the number of people that our camera sees. But we could even go one step further. If we implemented something like this, we could try and understand if those people that we're seeing are sitting down, if they're lying down, if maybe they're slumped forward, maybe their body language is telling us something about how they feel in the space and how they're experiencing the world around them. Or it could be something different altogether. That's totally up to you. And if we have time, we'll wrap it into this lab. But if not, again, I'll put that out there for the community as a little challenge. The glitch modules are going to be there for you to just easily fork and remix. So if this is something that you're interested in, highly encourage you to do it. All right, so going back to the cookie stack a little bit. So I want to talk about why these technologies are coming together for this lab. So first and foremost, the lab is a learning opportunity. We're not making products for a startup, and we're not going to market tomorrow. The goal of this was to really provide a diverse set of learning opportunities so that no matter what your experience and background is, that there's hopefully something you can pick up and learn. So here's why the different pieces are what they are. So view, like I said, we're gonna visualize the output of the camera. It's gonna help us debug and understand what the model is going to be seeing and how we expect it to predict things. But it's also a good opportunity to get into some front-end web development. Vue is a very new, modern framework, very popular and gaining popularity by the day because it's so easy to use, it's fast, easy to understand, and it gets you up and running and creates some fantastic products right out of the box. So if you haven't been experienced or haven't been exposed to front-end development, this is a good one. Tensorflow JS. So there's obviously a rabbit hole of TensorFlow we can go down, and that's been around for a while. On the Python side, on the JS side, it's a little bit newer, but it doesn't mean that there's any less depth. Um, what we're going to use from TensorFlow, however, is not so much the ability to create a custom model, but the ability to consume models that have been pre-trained for us. And the reason is, again, this is an introductory workshop. If you really like building the custom model and you want to get deep in TensorFlow, the documentation's out there, and there's a lot better tutorials than this because I don't have a PhD in applied mathematics or machine learning. I know how to use some parts of it, but I'm absolutely not qualified to teach that. So TensorFlow is going to get her feet wet and just show us the power of what's out there and show us how to leverage existing models. Brain.js is going to get her feet wet in terms of creating those models. So again, if you really like what Brain.js is letting you do, but you feel like there's not enough depth, you could totally jump right back into TensorFlow and do the same thing, but with a lot more detail and control. And the last one is Express.js. So we're going to create a very simple backend API. It's mostly going to be to just do some analytics using our predictive model, but it's also going to expose us to how to create a very basic API, how to just create a web endpoint, which you can deploy anywhere and you can access from anywhere and do things like computation or just do things like return some data. So I think those are all some very interesting pieces, and hopefully there's something in there that you have not learned or seen or worked with before. So a little bit about Glitch as well. So this is kind of what your editor environment is going to look like. It should be pretty familiar if you use IDEs on a day-to-day. On the left hand, we have our tree of files and folders and all that good stuff. And on the right is really just the main view of the file that we're looking at. So for all of these modules, there's going to be a README, which tries to outline some of the most critical parts of that module. And there's going to be obviously project files as well in the left. So there's some very useful controls, I think, when you open up one of these projects. So if you, the mouse isn't in the screenshot, but if you mouse over here over the title and you click on it, this will expose a list of controls. So new project, that I think everybody understands what that is. Remix project is the one that I want to talk about. So this guy right here, that basically allows you to fork the project if you're familiar with GitHub. And if you're not, basically means that you're going to create a copy of this project for yourself that you can work with. And I think that's pretty cool because, again, you don't have to code along if you don't want to. You can just remix one of these modules and start playing around. If you mess something up, you can just go down here, delete it, and start over. Another very useful set of controls I just want to expose before we get right into it. So bottom left-hand corner, very much at the bottom of the vertical stack that we just looked at, there's a tools pop-up, and there's some useful things like logs, terminal. Those are useful if you're debugging something and want to understand what errors you're getting. And then rewind is the one that I think is the most interesting. So this basically is like a draggable timeline that you can use to go back in time. If you made a mistake or you just want to go back to a snapshot that you have created while working, this allows you to do that very easily. And sometimes if you're debugging something funky, it's just easy to be able to step back and try and analyze what's going on and where. All right, so how do you follow along? I think there's a lot of different options, and you can do any of these or none of these really. So my favorite one is just to remix and tinker. So once you get the glitch link, you can just pop around, make some copies of those little modules for yourself, play around, change things up as you watch the videos and afterwards. And just learn that way. You could also completely start fresh and code along, so you can open up Glitch and create yourself some new projects. And as I'm talking through the different modules, you can try and create the same thing for yourself. Or you could just simply remix and listen or explore. So you don't have to do any coding. You can just watch and yeah, follow along. And the last one is collaborate, share, or assist using glitch sharing. And I think this is a pretty cool one, especially now at the time of this recording when a lot of us are working remotely, working from home. But glitch sharing is a cool feature from Glitch. It basically lets two or more people jump into one project. So, if you're working with someone and maybe they're struggling a little bit and you're farther along in the modules, you could very easily just use glitch sharing, jump into their instance, and code along with them and help them understand maybe what you've already gone through. Or you could just get a group of people and jump into one instance so that you guys are all working together as opposed to each doing it their own way. So really cool feature. Highly encourage everybody to look at that one. And if you're more advanced, how do you follow along? Well, you could do all the things on the previous slide, just absolutely breeze through them. But here's also some other things that you could help out everybody else watching. So you could add that database connection module, again, either on Glitch or otherwise. You could try PoseNet as an alternate to the Coco SSD image recognition model that we're going to use. You could, of course, get deep into TensorFlow.js and Brain.js documentation. You can build some more advanced predictive models, some neural networks, which are more tuned to hyperparameters and make more sense with the data and help us make some more accurate predictions. And you can, of course, just experiment with different configurations, other things like that. Use it as a sandbox, really up to you. I would highly encourage you, if you come up with something fun and useful, to share it with everyone else. I think we'd all really love to see the different flavors this takes on. So how are we going to structure all of this? The beginning part will, again, be really about the image recognition. So we're going to use Vue to render a web page, and we're going to connect it to our webcam, and hopefully your device has a webcam. If not, there's other things we can do, like load in a video source from somewhere else. But hopefully your device just has a basic webcam. We'll use that to read some images. We're going to pass those images to the TensorFlow.js predictive model, and we're going to get information out of that. So why are we using Vue? I know I mentioned a little bit before, but just to sing some more of its praises, I think the slide here says it all: approachable, versatile, and performant. Highly recommend using this in other projects as well. The documentation is really, really good. So hopefully this is one of the linked ones. Yes, it is. Check out their documentation. I feel like it's very easy to read. You can almost just read it like a book, start at the top, go down. It gives you, honestly, all of the most critical things to build a really effective web experience, I think. Highly also encourage you to install Vue.js DevTools. So this workshop is going to work best in Chrome, and DevTools are really going to allow us to debug and understand what's going on in the Vue instance, which is going to be critical to make sure that data is going to the right places and we're collecting the right types of information so that our model can work and analyze. TensorFlow.js is another critical part of this. So I said that it's on the newer side, but their website is very robust. They have a lot of documentation there, tutorials, guides, demos, all that good stuff. So if your interest is more on the TensorFlow side, highly recommend you checking it out. And again, this slide is hyperlinked, so just feel free to click. So on the TensorFlow.js website, they have a lot of examples as well. You can see on the top, there's a lot of very diverse medium in which those examples are working. So obviously you can kind of imagine the browser is the biggest sandbox that there is. And highly encourage you to explore through some of these and see if there's anything that might be of interest to you. There's some more traditional examples on the bottom. You can see like text classification, hand tracking, or I guess corporal tracking. Stuff like that. So all kinds of really good content. Brain.js is, like I said, a much more high-level library than TensorFlow.js. So this is going to expose a lot of the parameters for us to create neural nets, but it's also going to allow us to do it with the minimum overhead as possible. So this is kind of the most rudimentary implementation, and you can see that this is like, what, 5, 6 lines maybe, and we have a basic neural net. Is it going to be perfectly tuned and optimized? No, but it's a good example of how we can be up and running and get into the specifics and other complexities as we can. So they have some, again, much more detailed tutorials on Brain.js than what we're going to go through here. We're going to use it just to get up and running, but this is another one of the hyperlink slides. It's a lesson series on Scrimba from the creator of Brain.js. And he shows a lot of different examples using different data types, numbers, strings, long short-term neural nets, all kinds, and they all have very different applications and use cases. So again, highly suggested that you check this out if this is your specific interest. I also want to do a quick thanks for the data sets that we're going to use for the predictive and analytical model. So for the purposes of this workshop, obviously we are not going to collect huge data sets in databases. So we had a little bit of help from Spacebot. And Spacebot is a startup company that basically does what we're talking about, but much more sophisticated with the right hardware and the right software. And they're creating these IoT devices that they can place around their client spaces and collect different information about those spaces to hopefully create some intelligence and insight for those clients into how they should be managing those spaces better and more efficiently. So David and Keith have provided a sample data set for us that was collected from a client's office somewhere. So the data is all encrypted, anonymized. It's in the form of a CSV file that we're going to consume later. So we're going to use a part of that to create a predictive model that's a little bit more richer and has a little bit more training data than we're just going to be able to create in a couple of hours or something like that. And especially for those of us that don't have access to a conference room or a big office, and might have to rely on the analytics that cut them out of our own webcam, which wouldn't be very many. So this is kind of what their product looks like. And like I said, it's similar in concept, but much more sophisticated. So their hardware is a Raspberry Pi unit with a vision sensor and a Wi-Fi signal emitter. And this is kind of the stack of what they do and the information that they collect. All right, so what's the finished project going to look like? There will be two parts. So the first part will be the little front end sensor itself. So this is just going to show us the video feed, and it's going to tell us if a person is detected and how confident the model is that that's a person. And the second part is a little bit, I guess, more difficult to put into an exciting image, but it's going to be our custom model. So like I said, we're going to use Brain.js. We're going to create a neural net, and we're going to get some predictive analytics out of it and then basically serve it over an API so that we can pass different information to it and get different outputs out of it. So that's what that's going to look like, a little bit less exciting. But yeah, that's going to be what we're going to be building. So hop on over to part 2 and let's get started.